Hello class. This is the molds and mass lab, and the materials required for this lab. I have I have to actually, since I'm going to measure the mass of sugar, salt. So I'm going to be using two graduated flask. Two graduated cylinder. I'm sorry. I have my tumbler. I'm going also to use two Erlenmeyer flask, and I have my beakers, and this is sugar, hydrogen peroxide, and salt. And right here I have cutting potatoes. Right here. The potatoes are right here. Okay. Step one. Oh, and I have the scale. My little scale right here. Step one, Erlenmeyer flask and graduated cylinder. 20 milliliter of salt in the graduated cylinder. 20 milliliter of salt in one of the graduated cylinder. Then 15, 20 milliliter of salt. And then here's my tumbler, so I don't make a mess. I have a little bit too much. I'm gonna pour some out in the sink. Okay. So kind of much. Oh my goodness. I'm a little heavy-handed. Okay, yes. I have 20 milliliter of salt. I don't know if the camera can show you. 20 milliliter of salt. Right here. 20. I don't know if you can see it. Just 25, 20. Yep, 20 milliliters of salt in the graduated cylinder. Step 3, I'm gonna weigh the Erlenmeyer flask using my balance. And turn it on. Okay, I'm reading 74.77 grams for the Erlenmeyer flask. Let me write that down. Erlenmeyer flask. 74.77 grams. Okay. Step 4, pour the salt into the Erlenmeyer flask and measure the mass of the Erlenmeyer flask with the salt. said before. I'm going to put this graduate cylinder out the way since I'm going to use the second one. I don't know if that's necessary, but I don't want any grain of salt to remain in this one, so I put this away. Okay, now I have my Erlenmeyer flask with the salt, and I'm going to weigh it. I have 100.10 grams of, that's the mass. 100.10 grams. Keep fluctuating. 10, perfect. 100. That's the weight of the Erlenmeyer flask and salt. Erlenmeyer flask with salt. 100.10 grams. In step 5, calculate the mass of the salt. Mass of the salt will be the mass of the Erlenmeyer flask with the salt minus the Erlenmeyer flask empty. So it's the mass of the Erlenmeyer flask with the salt minus the mass of the Erlenmeyer flask empty. 100.10 minus 74.77. Use my calculator. 74.77. I'm reading 25.33 grams. That is the mass of the salt. Yes. 25.33 grams. Okay. Now to calculate the mole of the salt. Yeah, calculate step 6. Calculate the moles of salt. First, I need to calculate the molar mass for 1 mole of salt, which is NaCl, which is sodium chloride. Salt, yes. The molar mass of sodium is 22.99 grams, and chlorine is 35.45. Alright. 22.99 plus 35.45, 58.44 grams. That is the molar mass of 1 mole of salt. 58.44 grams. Now to calculate the mole of salt, it's to calculate the mole of the 25.33 grams of salt, which is 25.33 grams times 1 mole per 58.44 grams. That's 25.33 divided by 58.44. That's 25.33 divided by 58.44. It's 0.433 mole. 0.433 mole. 0.433 mole. This is the mole of salt. This is the salt. Now I'm gonna put that away. I have a clean Erlenmeyer flask, a clean graduated cylinder, and I'm gonna put the salt away. Now we're gonna do with sugar. Okay. Step 7. Step 8. 20 milliliter of sugar. Yes. Ooh, I have to take, I have to. Yes. 20 milliliter of sugar. Where's my turner? Oh, turner's right here. I'll make the spoon. Put that away. I have. Tiny bit more. Okay. Put the sugar away. 20 milliliter of sugar in the graduated cylinder. Bring it closer to the camera. $20 milliliter of sugar. Okay. 20 milliliter of sugar in the graduated cylinder. Okay. And first, we have to weight the Erlenmeyer flask again using the balance. So, I'll turn it on. Hopefully, it's the same. Right. Oh, this one is different, a little bit different. I'm reading 75.34. That's for the sugar. For the sugar, the Erlenmeyer flask I'm using for the sugar is reading 75.34 grams. Erlenmeyer flask 75.34. That's the weight of the Erlenmeyer. That's 75.34. 75.34 grams. We're gonna put the sugar, pour the sugar in the Erlenmeyer flask. Pour the sugar in the Erlenmeyer flask and measure the mass of the Erlenmeyer flask and sugar. Same thing, I put it for the salt. Actually 93 even. 93 grams. That's the Erlenmeyer flask with sugar. $93 even. Okay. And we're going to calculate the mass of the sugar, which is the same as we did for the salt. It's the weight of the Erlenmeyer flask with the sugar minus the weight of the Erlenmeyer flask empty, which is 93 grams minus 75.34. Calculator. 93 minus 75.34. 75.34. I'm gonna do that one more time to be sure. minus 75.34. Okay, I'm reading 17.66 grams. 17.66 grams. Okay, now that's step 12. Calculate the mass of the sugar. Step 13. Calculate the moles of sugar. Now, to calculate the moles of sugar, we have to calculate the molar mass of sugar first, which is C6 is 1206. C6 is 1206. We're going to calculate the molar mass of that. Carbon is 12.01. 12.01 times 6 plus hydrogen 1.008 times 12, and oxygen, which is 32 times 6. No, 16 I meant to say. Ooh. Yeah, 16. Oxygen is 16. Yeah, 16 times 6. Okay, so let's calculate that. Times 12. 12.096 and 16 times 6 minus 6 plus 12.096 plus 7606.06 184.156. This is the molar mass for one. This is the this is the molar mass for 1 mole of sugar. Now we're going to calculate the mole of sugar for the 17.66 gram of sugar that we measured. So we're going to calculate the mole of sugar for the 17.66 gram of sugar. Okay, so 17.66 times 1 mole per 184, 156, 17.66 divided by 184.156. We'll calculate that. 17.66 divided by 184.156. 0.095, 958 if I round it up. Yeah, 0.958 or 957, I would say. 96, 0.096 if I round it up. 0.096, 0.096, yeah. So 0.096 mole. That's the mole of sugar for the 17.66 gram of sugar. Okay, that's the mole of sugar. Okay, I'll do the calculation on the piece of paper. All right, now step 14. 30 milliliter of hydrogen peroxide in a beaker. I have my hydrogen peroxide. I'm going to put the sugar away. Okay, I'm going to put, alright, all this away. Alright, 30 milliliter of hydrogen peroxide in the beaker. peroxide. 30 milliliter. Wonderful. Okay, you can read that. I'm going to pour it in a bigger beaker since I'm going to have to put the potatoes in there later. But first, I wanted to measure 30 milliliter of hydrogen peroxide in the beaker. You're gonna see. If I can zoom it in perfectly. More lights. 30. It's right on the mark. 30 milliliter of hydrogen peroxide. Okay. Okay. I'm going to pour it into a bigger beaker. Okay. And I have the cut up potatoes right here. Just get it away. And cut the potato into small pieces. The potato is the catalyst. Put the potato in the beaker and record my observations. Alright, they already cut up, so I'm gonna add them into the beaker all at once. And I'm going to time it. You see, we set a timer. Okay. Put my timer. It's bubbling at the surface level. It's foaming on top. I would say it's been 1 minute and 30 seconds. Going to 2 minutes. still foaming. It's mostly foaming on the surface level. Nothing going on at the top, at the bottom. I mean, it's mostly foaming at the surface level, and it seems like the foam is slowly. The reaction is slowly coming to an end. I think it stopped right now. Yes. Yeah, I would say it stopped. I would say that it took up to 4 minutes. Yes. It took up to 3 to 4 minutes. I would say 5 minutes. Yes. I would say so 5 minutes. Actually, it starts. I would say within the 30 seconds as soon as I dropped or I put the potatoes in the hydrogen peroxide solution. As soon as I put the potatoes in the hydrogen peroxide solution, I can see the reaction starts about 30 seconds after putting in the solution. And hold on a minute, it's still bubbling at the bottom. Right here. Oh yeah, it's still bubbling. No, yes. I'll take that back. Yeah, it's still bubbling. Especially right here. You can see a lot more bubble coming up right here. Oh yeah, it's foaming more and more. I was wrong. There's a lot more foam coming up. It's bubbling more. foam on top. Still bubbling at the bottom. More foam on top. Seems like it's stopping right now. For sure. I don't think it's bubbling anymore. It's just trapped gases at the bottom. Air traps. I mean, well, I don't know if it's gases or not. I would say, yeah, gases. Yes, they're still coming on top right now. It's still bubbling. All the gas, yeah, right here. You can see it's still bubbling right here. A lot more foam. Okay. Well, I don't think it's stopping anytime soon. Yes, it's still bubbling. Yeah, it's still bubbling. I guess it's a continuous reaction. I don't know if I'm right. Alright, I'll write that it takes up to 10 minutes. I'll show you at this point right now. 10 minutes and up. The reaction starts within 30 seconds of me putting the potatoes in the hydrogen peroxide. Within 30 seconds of contact with the solution, I started to see a reaction. I would say 30 seconds. Yeah, 20 to 30 seconds. 20 to 30 seconds. Okay. And as of right now, it is still bubbling. Yes, so I guess this is it. I'm going to end the video here. I don't know how long it will take to stop. It takes for the reaction to be completely stop bubbling. So yes, it's still bubbling. Not as much as not as much as when I first put it in the solution, but it is still bubbling. Yeah, it is still bubbling, but I would say that it is not as much as when I had first put the potatoes in the hydrogen peroxide. Um, it is still bubbling. All right, this is it. Thank you very much. See you guys on the next video.